So what you do is first you open Fluent and then click Geometry. This will open the geometry, and once that's opened, click on the XY plane and look at the XY plane. This will give you a view, and select lines under sketching, and you can draw the nozzle. Once that's done, you can put the dimensions for the nozzle to make it symmetric, or you can either use the symmetric tool to make it symmetric along the x-axis. Now we add the dimensions by the function called length and distance. This will add both the lengths, all the dimensions of the nozzle. Approximately there will be 9 dimensions that will be added to the figure, which will constrain it to have a symmetric dimensions. The length can be set by selecting the values on the left side in the details view under dimensions. It can be directly set there, and as you can see, it directly changes on the figure itself. Once that's done, you have a symmetric figure with all the dimensions that you have already set. The values here are in meters. It can also be set to millimeters from the units menu on the top. Now the dimensions are all set, and now after setting the dimensions, the sketch is converted into a surface by selecting the top tool and converting it to surface. All the edges are selected and applied. Once that's done, once setting everything, click generate and you have your surface. Go back to the workbench, update the mesh. This will take some time, and some text boxes. Now as you can see, the geometry has loaded, or it's about to load, and the bottom left corner shows the status of the geometry. Now we can select the front view of the object. Once that's done, we have to set up the mesh. Select the mesh option. Then you can see a drop down menu on the bottom left. Select proximity and curvature, and fine and high for smoothing. Now you can see the mesh has formed. Now we need to name the sides of the sketch. So the first side is the inlet side, and we name the walls as the walls itself with the help of this function. And after that, we name the outlet side too by creating a name selection. Now once that's done, what we do is we go back to our workbench and update the mesh. Give it some time for the mesh to update. Next, we set up the mesh. Leave the settings as it is and proceed and click OK. Once that's done, it will take some time, and it's almost done. Okay, now you can see your surface. Select density based solving and enable energy equations. Once that's done, you can have to specify the fluid, which is air, and as ideal gas. Select the density, then select ideal gas. Once that's done, change and create, and then close. After that, set the boundary conditions, go to the inlet, then select pressure inlet. Now, select the pressure inlet and set the values for gauge total pressure, which is 5 into 10 power 15 to 10 power 6, and we set the initial gauge pressure to 45 into 10 power 6. Once that's done, go to reference values and inlet, and then you can see the reference values there. You also have to set the monitors. You have to click create surface monitors, then drag, and that's how you set surface monitors to get the plot at the end of the simulation. Now, after that, go to solution initialization, select standard solution or standard initialization, and select inlet. Just let me recheck this once, and initialize. Now you get the temperature, velocity, and the gauge pressure. Click OK. Then go for run calculation. Set the number of iterations to either 100, 200, or whatever you may please. Then calculate. This may take some time. Now you can see the calculations are done, almost over. You can see the residual plot. Go back to the workbench, select results. After selecting results, allow access. You can see your geometry. Okay. Now select control to set the control plots, and okay, you can set the streamlines. Select streamlines. Select all domains, and you can select the number of points, and you have to start from the inlet. Number of points are 50. Now the streamlines are visible, and you can even run the animation, and you can see how the air flows through the nozzle. Now to get the contour plots, go back to your calculation part, go to graphs, results, contour plots, select the velocity, or select the pressure, static pressure, and this will display the results for static pressure, the contour plot for static pressure. You can also set it for Mach number and velocity, as you can see here. Therefore, those are the results, and that's the end of the video. Thank you.